Hi, and welcome to section 6.2. This section has two videos. This will be the first part of those two videos. In section 6.2, we will be looking at the trigonometry, or the trig, of right triangles. So a triangle is considered a right triangle if one of the angles is 90 degrees. So if we look at the picture, so two of the sides meet at 90 degrees, that makes this a right triangle. If we designate this angle here as our angle theta, the side opposite this theta is just known as the opposite side. The side connected to this angle is known as the adjacent side. And the long leg of this triangle, which is opposite the 90-degree angle, is known as the hypotenuse. So with this theta, we have the opposite, the adjacent, and the hypotenuse. So from this, we get the trig ratios. The first one, if we want to know the sine of theta, this is equal to the opposite, so I'm just going to abbreviate it, OPP, over the hypotenuse. So sine of theta, so if we want to know what is the measurement of this angle, it's the length of the opposite side over the length of the hypotenuse. Cosine of theta, so if we want to know this angle and we want to know the cosine measurement of this angle, this is equal to the length of the adjacent side over the hypotenuse. And if we want to know the tangent of theta, this is the length of the opposite side over the length of the adjacent side. How do you remember these? I'm sure you guys probably already know this, but there's the little expression SOHCAHTOA. So, S-O-H, co, C-O-H, toa, T-O-A. Sine is opposite over hypotenuse. Cosine is SOHCAHTOA, so C-A-H, sorry. S-O-H-C-A-H-T-O-A, SOHCAHTOA. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So again, for now you can put these on your cheat sheet, then you won't have to worry about remembering it. But for the final exam, you don't get a cheat sheet. You'll have to know this stuff. To be honest with you, we're going to do so many of these problems that you'll probably know these sides anyways. But at least for now in the interim, put it on your cheat sheet. Again, it becomes a quick reference for you. We have our three other trig functions though, right? So what trig function goes with sine? Well, that's cosecant. And using our reciprocal identities, cosecant is what? It's just if you flip that over. So cosecant would be the length of the hypotenuse over the length of the opposite side. Cosine is related to what? It's related to secant. So secant of theta, using the reciprocal identities, we flip it, so it's just hypotenuse over adjacent. And then lastly, with tangent is cotangent. So cotangent of theta is the length of the adjacent side over the length of the opposite side. All right, make sure you have those down. I'm going to erase this. We'll work an example. All right, so let's say we have the following example. We want to find the trig ratios for the following triangle. So we have this right triangle. One leg is square root of 5. The other leg is 2. The hypotenuse has length of 3. So sine of theta, so our theta is going to be down here. So sine of theta is opposite, which is 2, over hypotenuse, which is 3. So sine of theta is 2/3. Cosine of theta is the length of the adjacent, which is square root of 5, over the length of the hypotenuse, 3. So square root of 5 over 3. And tangent of theta is opposite, which is 2, over adjacent, which is square root of 5. This brings up a point. We have this radical in the denominator. On the homework, sometimes you'll have to rationalize this. On the exams, you might have to rationalize it. So how do we rationalize a fraction that has a radical in the denominator? Well, we're just going to multiply the top and bottom by that radical value. So if I have square root of 5 in the denominator, then I multiply top and bottom by square root of 5. I get 2 times square root of 5. And then square root of 5 times square root of 5 is square root of 25, which is just equal to 5. So the shortcut is really to put the radical up in top and then get rid of the radical sign in the bottom. That's the shortcut to rationalize these simple fractions with a radical in the denominator. So tangent of theta would be 2 square root of 5 over 5. How about our other trig functions? Well, sine is related to cosecant. So cosecant is if we just flip these two, which is 3/2. Secant is if we just flip this guy, so it's 3 over square root of 5. And again, the shortcut says put the radical up in top and get rid of the radical symbol in the bottom. So 3 square root of 5 over 5 would be our secant of theta value. And then lastly, cotangent of theta. Well, if we just look at the original part, we had 2 over square root of 5. So if I flip that, I get square root of 5 over 2. So that's my cotangent value of theta. So that's our 6 trig ratios for this triangle. Let's look at another example. So this example says that if cosine of alpha, so instead of theta, they're now using alpha. Don't let that throw you off. It could be beta, it could be mu, it could be any of the Greek symbols really will be the unknown value of our angle. So if cosine of alpha is equal to 3/4, then we want to sketch a right triangle with acute angle alpha and find the other five trig ratios of alpha. So we're given the one, which is cosine, so we want the other 5 trig ratios. So the first thing we need to do is draw this triangle so that I can actually figure out what's the length of my opposite, what's the length of the hypotenuse, and so forth. So if I draw this right triangle, if I put alpha as this angle down here, Well, I'm told that cosine of alpha is what? It's 3/4. Well, I know from my values that cosine is what? Cosine is adjacent over hypotenuse. So if my alpha is here, the adjacent side is the bottom of the triangle, so that would be 3. And the hypotenuse would be 4. So that gives me 2 of the 3 sides. How do I find the other side? Well, it's a right triangle, and so throughout the whole semester, if you're given a right triangle, which you will be most of the time, and you have to find an unknown side, we're going to use Pythagorean theorem. So if this is our unknown, let's call that x, then we have what? 3 squared plus x squared is equal to 4 squared. So a squared plus b squared equals c squared. One leg squared plus the other leg squared equals the hypotenuse squared. So now I need to do algebra to figure out the value of x. So I have 9 plus x squared is 16. If I subtract 9 from both sides, I get x squared is equal to 7. And so if I take the square root, normally it would be the plus and minus values, but in this case we don't have the length of triangle minus 7, so it's just going to be the positive value. So x is equal to square root of 7. So now we can figure out the other values. So sine of alpha is opposite, which is square root of 7, over hypotenuse, which is 4. Cosine we already had is 3/4. Tangent of alpha is opposite, square root of 7, over adjacent, which is 3. So now our other values are just the reciprocals of these. So cosecant of alpha is 4 over square root of 7, which again, if we do our shortcut, this is 4 square root of 7 over 7. We just take the radical to the top and get rid of the radical symbol on the bottom. Secant of alpha is 4 over 3. Cotangent of alpha is 3 over square root of 7, which is 3 square root of 7 over 7. So that gives us our 5 other trig ratios of alpha. First we had to find the unknown side of the triangle. Once we had that, we were able to use just our definitions for the trig ratios to find out these values. So that ends video 1 for section 6.2. I'll see you in the second part of 6.2.